Very nice question. The question that has to do with the volume of an area of a shape. So let's look at that one. The diagram below shows the body of a different submarine with a similar design. Now, the idea is here that we have a half of a sphere, we have cylinder, and we have a cone. The dimension of this submarine are all given in terms of x, where x belong to r. The hemisphere, cylinder, and the cone all have the radius of x. So we can see that this radius of x is the same for all of them. And then apart from that, we have a dimension here given, the length of them given in x. The submarine has a volume of 6,738 cubic meters, correct to the nearest cubic meter. By solving an equation in x, find the total length of this submarine and give your answer in meters correct to one decimal place. So again, what am I looking for? Total length. What will be my total length equal to? It will be this length x plus then the next length of 7x plus the next length of 4x. So that means my total length 1, 7, and 4 will give me 12x. That will be the total length. But in order to find that total length, I need to find the value of x. And all the numerical value that is given me have to do with volume. So in your question, when they are giving you an answer, like here, normally they will say, what is the volume? But when they are telling you, when they're giving you an answer, you have to ask yourself a question, well, how did they got that volume? Because it is what? They took no, that's my attempt of drawing a hemisphere. It's a volume of a hemisphere, then a volume of a cylinder, and then a volume of a cone, isn't it? So how do we calculate that? Well, we go to the table and we look for the formulas for each one of those. So volume of the sphere 4 over 3 pi r to the power of 3. Now, however, we need only half of it, so we are saying a half multiplied by 4 over 3 and multiplied by pi multiplied by radius to the power of 2. And then the volume of the cylinder. So what is that? The volume of the cylinder, pi r square h. So pi multiplied by radius to the power of 2 multiplied by the height plus, and then volume of a cone. So again, our table, 1/3 pi r squared h. 1/3 multiplied by pi multiplied by radius to the power of 2 multiplied by h. Okay. So let's fill in those values from what we have. So we know all of that is the volume, isn't it? That's how they got the volume. So we are saying 6,738 they got by multiplying. A half, 1 over 2, multiply by 4 over 3, multiply by pi, and then multiply by radius. And we are told that actually radius in all of them is x. So we're going to have x to the power of 2 plus. Actually, that's my mistake. That shouldn't be written power of 2. That should be power of 3, isn't it? Power of 3, and therefore power of 3. Then the next one, pi multiply, again radius we know is x, so x to the power of 2, and multiply by the height of the cylinder, and what is that? 7x. So multiply by 7 and multiply by x plus, and then the next one, 1/3 multiply by pi, multiply again the radius we know that is x to the power of 2, and multiply in the height of the cone we are told is 4x, so meaning 4 multiplied by x. Now the reason why I'm writing multiply sign everywhere so that you can see it, what multiplies with what. So all of that is a number, then pi multiplied by 7 is a number, then 1/3 pi, and then 4 is a number. So all of those are numbers. Then here I have, let's get a different, x to the power of 3. Then if I multiply x squared by x, I'm going to get x to the power of 3. And here again, x squared by x, if I multiply, I'm going to get x to the power of 3. Let's just write it down. So 6,738 will equal a half multiplied by 4 over 3 multiplied by pi multiplied by x to the power of 3 plus. Now here I'm just going to change the way it is written, 7 and pi, and then multiply by x to the power of 3 plus, again 1/3 multiplied by 4 multiply by pi, multiply by x to the power of 3. So we can see clearly each element have x to the power of 3. So what will we do next? Well, we're going to add all these numbers, isn't it? We're going to say all those numbers added, how much do we have? And again, you can either add it or write that you're going to add them, isn't it? Because that will be the value that will stand beside my x to the power of 3. So if I put all of that in the calculator, press equal, I'm going to have a number that will be standing beside x to the power of 3. Now I want x on its own, so all of that number that stands beside x is what multiply. So that means I divide both sides by this value. So I'm just going to kind of cut it a little bit short. I'm just going to add the fractions, since I can do that in my head, but that's okay. You can just put that in the calculator and add it. So now what do we have? We have our number, and now on the other side, whatever that value is. And then on the other side of the equation, we are left now with only x to the power of 3. How do I eliminate power of 3? We take what? That power tells me what number of the root, in this case third root, or what we know as cubic root, isn't it? So that is the value of x. Now, what was our total length? 12 multiplied by x. So that means that the total length will be 12 multiplied by our value of x. And yes, we can wait till, as long as if we get our numbers right, we can get to the very end and put all of that in the calculator, press equal and correct to one decimal place. We're going to get 74.4, and that was meters, and it was length, so just meters to one decimal place. That's our answer here. But that way you can see how the numbers move from one side of the equation, from here, all of them that can be moved to the other side of the equation, and then the total length we have.